Hey beautiful minds, welcome to Gen Z Learning. Today we are going to learn the chapter Dimensional Analysis. So let's begin. What do we understand by dimensions of physical quantities? Dimensions of physical quantities are the powers to which the fundamental units are raised in order to obtain the derived unit of that quantity. For example, here the dimensions are A, B, and C on the fundamental units length, mass, and time. And this particular formula is known as dimensional formula. Let's learn dimensional formulas of some physical quantities. The first one is area, whose formula is length into breadth, which is L into L, L2. Make sure you write them in brackets and also mention the fundamental units whose power is 0. For example, m naught L2 T naught. You can also remember the dimensional formulas with the help of their SI unit. So meter square, which is L square. The next one is volume. Volume's formula is length into breadth into height, which is L into L into L, L cube. M naught L cube T naught. Density is mass by volume. Mass is m, volume is L cube. So mass by volume, it will give us mass m L minus 3 T naught. Then velocity or speed, displacement or distance by time. Displacement or distance is L and time is t, which will give us m naught L t minus 1. Acceleration is change in velocity by time. Change in velocity is Lt minus 1 by time is t. M naught Lt minus 2. Force or thrust is mass into acceleration, where mass is m and acceleration is Lt minus 2, gives us mlt minus 2. Work is force into displacement. Force is mlt minus 2, displacement is L, we get ml2 t minus 2. Acceleration due to gravity is weight or force by mass, which is mlt minus 2 by mass is m, gives us m naught L t minus 2. Power is work by time, work is ml2 t minus 2, time is t, so we get ml2 t minus 3. Linear momentum is mass into velocity, mass is m, velocity is Lt minus 1, which will give us mlt minus 1. And kinetic energy is half into mass into velocity squared. Mass is m, velocity is Lt minus 1 whole square, which will give us ml2 t minus 2. Next is potential energy, whose formula is mass into acceleration due to gravity into height. Mass is m, acceleration is Lt minus 2 and height is L. We get ml2 t minus 2. Pressure and stress is force by area. Pressure and stress have the same dimensional formulas. So force by area, force is mlt minus 2 and area is L2, we get ml minus 1 t minus 2. Impulse is force into time, force is mlt minus 2 and time is t, we get mlt minus 1. Moment of force is force into force arm, force is mlt minus 2, force arm is L, so we get ml2 t minus 2. Force constant of spring is applied force by extension in length. Applied force is mlt minus 2 by length L, which gives us ml naught t minus 2. Coefficient of elasticity is stress by strain. Stress is ml minus 1 t minus 2 and strain is L naught. So we get ml minus 1 t minus 2. Surface tension is force by length. So force is ml t minus 2 by length is L. We get ml naught t minus 2. Surface energy is energy by area and energy is ml2 t minus 2 by area is L2, we get ml naught t minus 2. Velocity gradient is change in velocity by perpendicular distance. Change in velocity is Lt minus 1 and perpendicular distance is L, so we get m naught L naught t minus 1. Coefficient of viscosity is force by area into velocity gradient. Force is mlt minus 2 by area is L2 into velocity gradient, which is t minus 1. We get ml minus 1 t minus 1. Next we have gravitational constant g, whose formula is force into distance square by mass into mass, where force is mlt minus 2 by mlt minus 2 into L square by mass into mass is mm. So we get m minus 1 L3 t minus 2. Then gravitational potential is work by mass. Work is ml2 t minus 2 by mass is m, so we get m naught L2 t minus 2. Gravitational field strength is force by mass. Force is mlt minus 2 by mass is m, we get m naught L t minus 2. Frequency is 1 by time period, which is 1 by t, we get m naught L naught t minus 1. Radius of gyration is distance, which is L, get m naught L t naught. Moment of inertia is mass into distance square, mass is m, distance square is L2, we get m L2 t naught. Angle is arc length by radius, which is L by L, so we get m naught L naught t naught. Angular velocity is angle by time, so angle is m naught L naught t naught by time t, we get m naught L naught t minus 1. Angular acceleration is change in angular velocity by time. Change in angular velocity is m naught L naught t minus 1, time is by t, so we get m naught L naught t minus 2. Angular momentum is moment of inertia into angular velocity. Moment of inertia is m L2 t naught and angular velocity is t minus 1. We get m L2 t minus 1. Then we have torque, whose formula is moment of inertia into angular acceleration. Moment of inertia is ml2 t naught, angular acceleration t minus 2. We get ml2 t minus 2. Specific heat is heat energy by mass into temperature rise. Heat energy is ml2 t minus 2, mass m, temp rise theta. We get m naught L2 t minus 2 theta minus 1. Thermal capacity is mass into specific heat. Mass is m, specific heat m naught L2 t minus 2 theta minus 1. We get ml2 theta ml2 t minus 2 theta minus 1. Latent heat is heat energy by mass. Heat energy is ml2 t minus 2 and mass is m. So heat energy by mass gives us m naught L2 t minus 2. Coefficient of linear expansion is increase in length by original length into temperature rise. Increase in length L by original length L into temperature rise theta. We get m naught L naught theta minus 1. Coefficient of thermal conductivity K is heat energy into distance by area into temperature difference into time, which is heat energy is ml2 t minus 2, distance L by area L2, temperature difference theta, then time t, we get mlt minus 3 theta minus 1. Gas constant R is PV by T, that is pressure into volume by temperature. Pressure is ml minus 1 T minus 2, volume is L cube by temperature theta. We get ml2 T minus 2 theta minus 1. Planck's constant H is energy by frequency. Energy is ml2 T minus 2 by frequency is T minus 1, so we get ml2 T minus 1. Young's modulus Y is stress by strain ml minus stress is ml minus 1 t minus 2 by strain is m naught L naught t naught, which gives us ml minus 1 t minus 2. Please do not by heart these dimensional formula. Know their SI unit or their formulas, so it will be easier. Let's look into principle of homogeneity. Principle of homogeneity states that Every equation relating physical quantities must be dimensionally homogeneous, which means that the dimensions of each term of a physical equation must be the same. For example, here Q is heat, W is work, and X is some unknown physical quantity. What is the dimensional formula of Q? It is heat energy. It is ml2 minus 2. Work is also ml2 minus 2. So X should also be ml2 minus 2. Then only we can consider and use the principle of homogeneity for this, which states that all the terms of a physical equation must be the same. Q, W, and X must be the same. Next is uses of dimensional equations. The first use is to convert units of one system into the units of the other system. The product of the numerical value n of a physical quantity p and its corresponding unit u is a constant. Then we get the equation p is equal to n1 u1 of one system equal to n2 u2 of the other system. Then we consider this equation as our equation 1. Now we add the fundamental units MLT with dimensions ABC to both the systems and put them into the equation 1, cancelling out the common p. We get n1 m1 to the power a, l1 to the power b, t1 to the power c equal to n2 m2 to the power a, l2 to the power b, and t2 to the power c. Since we have to convert the units of one system to the units of the other system, we get this equation. N2 is equal to N1, M1 by M2 whole A, L1 by L2 whole B, and T1 by T2 whole C. Using this formula, we will be doing few of the examples. Let's look into the first example. Convert 1 Newton into dynes. Newton is the SI unit of force and dimensional formula of force is mLT minus 2. And we will be converting it from MKS system to CGS system, which is meter, kilogram, seconds, and this will be centimeter, grams, and second. Using this formula, N2 is equal to N1, M1 by M2 whole A, L1 by L2 whole B, T1 by T2 whole C. N2 is equal to 1 because 1 Newton, M1 will be converted to kg and M2 G, so kg by G whole 1 because M1, L1, T minus 2. So M1 and that's by kg by G whole 1, then M by Cm whole 1, then S by S whole minus 2. So N2 is equal to 1 into, we will be converting kg to grams, meter to centimeter, and yeah. So 1 kg is 1000 grams whole 1, then 1 meter is 100 centimeter whole 1, then S by S we get 1, so 1 whole minus 2. So N2 is equal to 10 to the power 5 because 10 to the power 3 into 10 to the power 2 we get 10 to the power 5 and 1 whole minus 2 is 1. So 10 to the power 5 is the answer. Let's look into the next example. Convert 15 joules into erg. And joules is the SI unit of work. And dimensional formula of work is mL2 T minus 2. So using this formula, N2 is equals to N1, M1 by M2 whole A, L1 by L2 whole B, T1 by T2 whole C. N2 is equal to 15 because 15 joules. Kg by G, M1 by M2, here the same thing. Whole 1 because M1 is 1, and then M by Cm whole 2 because L is 2, and then S by S whole minus 2 because T is minus 2. So N2 is equal to 15 into 1 kg is 1000 grams whole 1 into 1 meter is 100 centimeter whole 2, and then S by S we get 1 whole minus 2. So N2 is equal to 15 into 10 to the power 7 because 10 to the power 3 into 10 to the power 4, 2 into 2, 4. We get 10 to the power 7 and 1 whole minus 2 is 1. So N2 is equal to 15 into 10 to the power 7 is the answer. Next use is to check the correctness of an equation. We must make sure that the dimensions of the left hand side and right hand side are same. Then we can consider the equation to be correct, otherwise not. It is kind of similar to principle of homogeneity. So for example, we have to check the correctness of the equation 1 half mv square equal to mgh. M here mass, v is velocity, Lt minus 1, v square, so Lt minus 1 whole square equal to m mass, g is Lt minus 2 gravity, height is L. So we get m L2 t minus 2 equal to m L2 t minus 2. Hence both are equal, so it is correct. And the next example is v square is equal to u square plus 2as. It is one of the equations of motion. So velocity is Lt minus 1 v square, so Lt minus 1 whole square equal to initial velocity whole square, so Lt minus 1 whole square plus 2. This one is acceleration, here A is acceleration, so Lt minus 2, and S is displacement, so L. We get L2 t minus 2, then L2 t minus 2 plus, since 2 is constant we remove it, so L2 t minus 2. Since all the three sides, all the three terms are same, hence the equation is correct. Then the next use is to establish the relation among various physical quantities. Example 1. The time period t of a simple pendulum depends on length of the pendulum L, acceleration due to gravity g, and mass of the bob m. Derive an expression for the time period using dimensions. So from the question we get to know that t is directly proportional to L to the power A, G to the power B, and M to the power C. So to replace the directly proportional symbol with equal to symbol, we make use of K, which is a dimensionless constant. So we get the equation T is equal to K, L to the power A, G to the power B, and M to the power C. We consider this as our equation 1, and then the dimensional formula for time period is m0 L0 T1 is equal to, since k is a dimensionless constant, we remove it, and then L is L whole A, G gravity is Lt minus 2 whole B, then mass is M whole C. Then we continue m0 L0 T1 is equal to, and in this step we get all the dimensions together like B and B. So LA, LB, T minus 2B and MC. and in the next step we get all the fundamental units together. For example, m naught L naught T1 is equal to L A plus B T minus 2B then M C. Now we arrange the right hand side in the form of the left hand side. M L and T. So m naught L naught T1 is equal to m to the power C L to the power A plus B T to the power minus 2B. Now using equation 1, T is equal to K L G M. How do we get these dimensions? We'll just show you. Now from here we can see that C is equal to 0. C is equal to 0. Then A plus B is equal to 0. Since we can't do anything right now here, we'll go on to B. So minus 2B is equal to 1. Minus 2B is equal to 1. So B is equal to minus 1 by 2. So since we get B 1 minus 1 by 2, we can put the B here. So A minus 1 by 2 is equal to 0. The third use is to establish the relation among various physical quantities. Example 1. The time period t of a simple pendulum depends on length of the pendulum L, acceleration due to gravity g, and mass of the bob m. Derive an expression for the time period using dimensions. So from the given example, we know that t is directly proportional to L to the power A, g to the power B, m to the power c. To remove the directly proportional symbol and to put the equal to sign, we make use of k, a dimensionless constant. To get the equation, t is equal to k, L to the power A, g to the power B, m to the power c. Now we will be considering this equation to be our equation 1. Next step is dimensional formulas for each term. For t, m naught L naught T1 is equal to, since k is a dimensionless constant, we remove it. Length is L whole A, gravity is Lt minus 2 whole B, mass is m whole C. Next step is getting the same dimensions together. For example, B and D here. So we get m naught L naught T1 is equal to LA LB T minus 2B MC. Next step is getting together the same fundamental units. We get m naught L naught T1 is equal to L to the power A plus B T to the power minus 2B M to the power C. In the next step, we need to arrange the right hand side in the order of ML and T in the left hand side. We get m naught L naught T1 is equal to m to the power C, L to the power A plus B, T to the power minus 2B. Next, we need to find the values of dimensions A, B and C. So, A will be A plus B is equal to A plus B is equal to 0. We cannot do anything here, so let's move on to the next one. B minus 2B is equal to 1. So B will be equal to minus half. When we put this here, we get A minus half, which is equal to 0, which will be A will be half. Then the next one is C. C is equal to 0. And then with these values, using equation 1, this equation, we get T is equal to K L. L A. A value is half. So L half G is B. So B is minus half. G minus half and M is 0. C. So we write here 0. Then T is equal to K L half by G half. Since here it is minus, we get this G in the denominator and get G half. Then T is equal to K root L by G. Why root? Because root cancels the halves. Then the answer will be T is equal to K root L by G. Let's move on to the next example. The force on a body F moving in a circular path depends on its mass m, velocity v, and radius of the path r. Derive the formula for force using dimensions. So we know that force is directly proportional to m to the power a, v to the power b, r to the power c. So to remove the directly proportional and put the equal to sign, we require k. So F is equal to k m to the power a, v to the power b, r to the power c. This will be considered as our equation 1. Next step is dimensional formulas. So force dimensional formula is m1 L1 T minus 2 is equal to k is a dimensionless constant, so we remove it. So mass will be m whole a, velocity Lt minus 1 whole b, radius is L whole c. Next step is getting together the same dimensions. So m1 L1 T minus 2 is equal to ma Lb T minus b Lc. The next step is getting together the same fundamental units. So we get m1 L1 T minus 2 is equal to ma Lb plus c T minus b. Next step is to get the values of the dimensions a, b and c. So value of a will be 1 because a here, 1 here. Then b plus c will be 1. Since we don't know the value of b or c, we will continue to the next one. Then minus b will be minus 2. Minus b will be minus 2. So b will be 2. Then we can put this value here. We will get 2 plus c is equals to 1. So c is equals to minus 1. Using these values, we'll put here. So using equation 1, F is equal to K M A is 1, so M1, V B is 2, so 2, then R C is minus 1, so minus 1. Then F is equal to K M1 V square by R because R minus 1, so R will go in the denominator to get the positive value. So the final answer will be F is equal to Km V square by R. Then let's move on to the limitations of dimensional analysis. First point, the value of any dimensionless constant involved in the formula cannot be calculated. For example, the K, which was also a dimensionless constant. Next, the equation containing trigonometrical, exponential, and logarithmic terms cannot be analyzed. Third one, dimensional formula may not require a unique physical. Next is limitations of dimensional analysis. First one, the value of any dimensionless constant involved in the formula cannot be calculated. For example, the K is also a dimensionless constant. In the previous sums was not calculated. Next one, the equation containing trigonometrical, exponential and logarithmic terms cannot be analyzed. Next one, dimensional formula may not represent a unique physical quantity. For example, work is equal to torque. Work's dimensional formula is ml2 t minus 2, whereas torque's dimensional formula is ml2 t minus 2. They both have the same dimensional formula, but their nature is different. Hence, it does not represent a unique physical quantity. Fourth one, if a physical quantity depends upon more than three factors, then relation among them cannot be established because we can have only three equations by equalizing the powers of m, l and t, and only the values of three unknowns can be calculated. Congrats guys, you made it till the end of the video. Thank you for watching and hit the subscribe button for more such videos. Bye bye.